visibility, no prospect of a change for hours. Under such conditions, the pilot calls upon radio to become his eyes. The pilot who knows his radio and his instrument flying can utilize special radio aids in conjunction with his instruments to land safely even in most adverse conditions by following the Air Force instrument landing system. When a pilot wishes to make such a landing, he uses the radio compass for approach alignment, a special runway localizer to determine runway position, the altimeter for altitude, the directional gyro, and artificial horizon in holding his glide path, and a marker beacon receptor for locating the two special guiding stations. These guiding stations are usually established in trucks so that they may be moved about and set up according to wind conditions. Each station is equipped with a radio compass locator and a beam projector, which actuates the marker beacon receptor in the airplane. A new device now being added to the basic compass locator system is the runway localizer, which operates as a miniature range station. The guiding stations are set up on the downwind side of the field. The inner station is established near the edge of the field. The outer station is located 3.5 miles from the inner station. The runway localizer is placed on the upwind side of the field. Thus, a line drawn from the outer station through the inner station and the runway localizer is into the wind and straight along the runway. Following the radio range, an airplane approaches the field on which it is desired to make an instrument landing. Homing with the radio compass, it is flown to the inner station. Here, the compass immediately is tuned to the outer station. Thus, the approximate runway alignment is determined and set up on a directional gyro. At the outer station, a turn is negotiated and altitude is lost, so that the airplane returns to the station at a specified height. Here, the compass is immediately tuned to the inner station. While flying in on the compass, the gyro is checked and the exact runway alignment is established. Meanwhile, as seen here in a side view, a glide has been started so that the airplane will reach the inner station at a predetermined altitude. From the inner station to the actual landing, a steady glide is held. The compass is disregarded, and control is maintained by the runway localizer, the directional gyro, and the artificial horizon. Thus, the basic principles of the instrument landing system can readily be seen. By alternately tuning his radio compass to the two stations, a pilot is able to determine the exact alignment of the runway and verify this by means of the runway localizer. By coordinating this line with his altitude at 2 points of known distance from the field, he is able to establish his heading and glide so as to effect a landing with no visual reference to the field. The detailed procedure for making an instrument landing will be demonstrated here on the instrument trainer, where by leaving the hood off, the pilot's activities can be observed in the cockpit. The flight path is accurately traced on the recorder. Arriving in the vicinity of the field, the pilot contacts the tower to make sure that the instrument landing equipment is set up and to secure field and weather information. Upon learning the field elevation pressure, he sets it on his altimeter pressure scale. The altimeter must be set with extreme accuracy so that the exact elevation above the field will be known at all times. Now, to begin the actual landing procedure, he tunes to the inner station and centers the radio compass. At this time, he also tunes in the runway localizer and then turns on the marker beacon receptor. The directional gyro is caged at 180 degrees to be used later. At an altitude of about 1,000 feet, he flies to the inner station. A flash from the marker beacon receptor indicates that he is directly over the inner station. After receiving this signal, the pilot tunes to the outer station, centers the radio compass, and uncages the directional gyro at 180 degrees. Guided by the radio compass, he flies to the outer station. Upon reaching the outer station, he continues for 30 seconds at 180 degrees on the gyro. At the end of this time, he executes an offset turn. This is accomplished by first turning 60 degrees to the right for 20 seconds, and then executing a standard rate turn to the left for approximately 270 degrees. During the turn, he slowly loses altitude to 800 feet. The turn is stopped when the radio compass is centered. When the flash indicates that he has returned over the outer station, the pilot does the following rapidly. Tunes to the inner station, promptly centers his radio compass, resets the gyro, if necessary, to 0 degrees, and establishes a 400 feet per minute rate of descent by proper use of the throttle, holding the airplane level or a little nose high by the artificial horizon. Guided by the radio compass, he flies to the inner station. When he reaches the inner station, altitude should be 200 feet. From this point, he disregards the radio compass. Continuing descent at 400 feet per minute, he maintains control by means of the runway localizer, the directional gyro, and the artificial horizon. On contact with the ground, the altimeter reading 0, he cuts the gun but continues to fly the airplane in direction and pitch until the tail comes down of its own accord. The basic situation, as demonstrated here, applies to all instrument landing problems. There may be some variations in the initial approach, but in every case, the most satisfactory way to get in is to pick up the routine pattern as soon as possible. In review, we approach the southeast leg of the beam, followed through to the cone of silence, past the inner station and the outer station, made a procedure turnaround, returned to the outer station, and flew straight to the inner station and landed at the field. In coming into land, should an altitude of 200 feet be reached short of the inner station, the airplane is leveled off at 200 feet. Arriving at the inner station, a rate of descent is established as before at 400 feet per minute until contact is made. On the other hand, should the pilot find himself above the established altitude limit at the inner station, he has no choice but to pull up, go around, and try for a new landing. The directional gyro and the artificial horizon are the principal instruments used in flying from the inner station to the field. Airspeed and vertical speed indications can be considerably smoothed out with the aid of the artificial horizon. As long as it functions correctly, it has no lag, and its indications require virtually no interpretation on the part of the pilot. For losing altitude and landing, the artificial horizon is held in the same position as for medium-slow cruising. In this slightly nose-up position, the descent is more readily checked when power is applied than if a more nose-down position were assumed. When using the artificial horizon, Remember that as small a change as 1/32 of an inch in the pitch indication corresponds to a 1 degree raising or lowering of the nose. The Air Force Instrument Landing System has been proved in actual service. It is adaptable to many different types of airplanes with no fundamental changes. It fits practically all site and field conditions with a minimum of variation. And it can easily be mastered by pilots in a short time.